So, a little lightning fast stats to end off our school year. So, first off, measures of center. We're going to be talking about center and spread, but the three that you're probably familiar with already are mode, and that's the one that happens the most, the mean, and that's basically just the numerical average. You add them all up, divide by how many there are, and the median, and that's the middle one. So, if I were to take this set of data and I underlined them all to make sure that I had all the numbers, and I put them in order from smallest to biggest. Now, to find the mean, you add them all up. I've already done that, and it comes up to 132 when you add them all up. And then you divide by how many there were, and there were 11 numbers. And that comes out to 12. So 12 is the average. Now, that's the mean. Now, how about the median? The median's the middle one. And I like to do it this way for the middle one. I like to cross off a few on each end and just keep on crossing off a few until I'm down to just 3 numbers. It's the middle one. And of those 3, it's the 11th. So therefore, 11 was the median. And last but not least, the mode. Well, the mode is the one that happens the most. The problem is that there is nothing that happens the most on this one, and therefore there's no mode. There was never a repeat of a number. And so if there had been 2 20s, for example, then 20 would have been the mode. Now, mode is not really a great measure of the center of the data because just because there happened to be one extra 20 doesn't mean that that number is super special. So mode is kind of the one that isn't used very much. So now let's talk about how you could have done this on a calculator. So in the calculator, you would hit the stat button and then edit, and then we always want to put our data in list 1. And if you were to hit stat and edit, and it's the number 1 thing, and it's the left tab, then you can put your numbers in that L1 list. Then, after you've had a chance to put in all your numbers, then you can just go to stat and calculate one variable stats. So you'll see one var stats on the list under calculate. That's the calculate tab. I'm going to make a separate little video that just shows you actually me walking through putting numbers in a calculator. But then after you've done one var stats, it'll give you a choice of, well, what do you want to do it on? You want to do it on list number 1. Then you hit calculate and it pops up with your answers. So let's use that technique on these numbers. So I would recommend you try one of these with me. To be honest, this one has so many numbers, you may just want to watch what I did on this one. After I put in my numbers on list 1 and edited my list to have these numbers, then I went to stat, calculate one variable stats, and hit enter a couple times, and this is what pops up. It says X with a bar is 67.85. That's the average. This little summation symbol said 1357. That's what they all added up to. Then, skipping down a ways, it had this sigma x, and that one was the standard deviation, and that's 14.7. We'll talk about that at the end, what that really means. That's a measure of spread. And n equals 20, that's how many numbers there were. Then if you'd hit down arrow a few times, you can see a few more pieces of info. It says the min, x, the minimum number, and that was 25. It's telling you that the smallest number is 25. Q1, and Q1 is the first quartile. I'll explain that in a moment on a box plot. And then the median, MED, that was 71. That was the middle number. Q3 is one of the other end quartile, and that's 78. And then the max is 87. So what is the mode for this set of data? Basically, was there anything that repeated? There were 378s, and so that would be the mode for this set of data. All right. Now, I'm going to show you what this would look like as a box plot. This is important, so pay attention. There's a lot more of this coming tomorrow's lesson, but the smallest number goes down here, and our smallest number, our min, was 25. And our biggest number, our max, was 87. And then this Q1 is this spot right here. Q1 is 60, and our Q3 is 78. And the last thing we put down the middle, you might think it would be the average. It's not. It's the median. And the median is 71. It's a little closer to 78 than it is to 60. So notice the line doesn't go right down the middle of the box, but that's where 71 would be. And again, that's the median. Now, in understanding what a box plot does, this is your top quarter of the data. That's why this is called a quartile. And it's Q3, in fact. This one's Q1 over here. And that tells you the bottom 25% of your data. And then in this little spot, you have the next 25%, and here's the next 25%, making the big box. That's actually the 50%. That's the middle 50%. Okay, so that's like kids that are right in the middle in a school, for example. This would be like the very top kid. This would be the kid who's struggling the most. This is the kid who's exactly in the middle. And then this box goes around the 50% of kids that are right around the middle. So this represents 50% of your data. Two 25s, of course. There's 25 here and there's 25 there. All right. So now I'm going to just kind of finish the last things that you need to learn here on this slide. And that is, there's a range. The range is just the biggest minus the smallest. Okay, so to find the range, I just have to do 87 minus 25. And to find the interquartile range, IQR, if you know what a quartile is, that's these guys. It's just a range on those two. So you just go 78 minus 60. That's the interquartile range. All right. So let's go on. Take a look at, when do you pick mean versus median versus mode? Well, remember, mode is the one that happens the most. So there's certain situations that's good. The mean is the one that people use a lot, and it's easy to understand. You just add them all up, divide by how many there are. But the median is actually one of the best because it is not affected by extreme values. I'll give you an example. Let's say that you're taking the average price of houses in your area, but there's one super expensive house. If you put that into your average, it's going to throw the average off. But the middle house, that won't matter. That won't change because the big, super expensive house won't throw off the middle. All right, so median is honestly the best. And it's yet not used near enough because a lot of people think we just always should use the average, but they don't realize how much it can be thrown off by having a really big or a really small number. All right, so which one should you pick? Well, in shoe sizes, if you want to buy some extras of the shoe size you sell the most, that would make sense. That's a good use of mode. And it's saying here that they wanted the average profit. Well, then it sounds like you would want the mean on this one. And the reason they used home sale prices is because of that exact thing. There's sometimes houses that are way more expensive than the others, and it throws off the average. So you don't want to use mean, you want to use median. All right, let's move on. Now let's talk about some measures of spread. Mean, median, and mode are about the center, but this is more about spread now. Range and interquartile range, I showed you how to find those. As you zoom in on a box plot here, if I wanted the range of this one, I would say it's from here to here. Not a very big range. Whereas this one has a much bigger range. Let's change colors. These red dots, see how much bigger that range is? The biggest one minus the smallest one. And then interquartile range is another way to judge it. That's where you go from like here to here, and you take the bigger minus the smaller, versus here to here. That's got a smaller interquartile range. Remember, between those red lines, that's the middle 50% of the data. All right. So this is just the official definitions, what I just described before. And if I'm going to take this data set now and put it into my calculator, I can use those features that we have under one variable stats to get my answer. So I've already entered the numbers in. I encourage you to pause me, enter these numbers into your list 1. It's under Stat, Edit. Okay, now that you got those numbers entered, if you go to hit Stat again, arrow over to Calculate. It's considered a tab on the calculator. And then hit either the 1 or the Enter to get one variable stats. Now I hit Enter, Enter, and it tells me that my X bar is 5.5. Now, I'm not going to write down everything here like I did last time. I'm just going to focus on the answers to the questions. So the next one we're going to need to answer our questions is the minimum, which is 1, Q1, which is 3, the median, which is 6, and the Q3, which is 8, and the max, which is 9. Okay, so now I'm going to show you how we would make a box plot for this thing and answer these questions A, B, C, D, and E. So I'm going to make a box plot first. Super simple. Smallest number, 1. Biggest number, 9. Q1 is 3. Q3 is 8. And the median is 6. That's closer to 8, so I'll make the line kind of closer to 8 here. All right. And now the median is 6. That was given on my calculator as MED. The lower quartile, that's this one, it's 3. The upper quartile is this one, that's 8. The range is the biggest minus the smaller. That's the 9 minus the smallest one, which is a 1. 9 minus 1 is 8. The interquartile range is the 8 minus the 3. It's the 2 quartiles, the bigger one minus the smaller one. And so that would be 5. All right. So now, is a measure of spread, is this data very spread out? One of the ways you can tell it is by kind of looking at this box here and seeing if this box is extra wide or extra narrow. That tells you whether the middle of the data is spread out a lot. Though in those numbers, the range and the interquartile range can be compared with other data sets. Because how spread out is this? Well, it's really only logical to compare it in the context of comparing it to other data. What if somebody else's scores weren't between 1 and 9? What if they were between 1 and 40? Well, then theirs are more spread out than yours. Their range is bigger. Okay. So standard deviation is a way to look at data, and it's very new for you, I know. You've never done standard deviation before. The standard deviation on the data set that we just looked at there was 2.6. So it has this little symbol. And what does that mean? That basically means that the average data point out of that big list of numbers, there were 15 numbers there, the average data point was this far from the average. Remember, the average of our data, in that case that we just looked at, the average of our data was 5.5. So if you grab a typical point off the list, I'm going to go look at my list here under Stat Edit, and say I grab the number 6, just one of the points that's on the list. If I look at 6 and I compare it to the average, which was 5.5, how far away was that 6 from the average? It was only 0.5 away from the average. Well, the average distance from the average is what this measure of central tendency called the standard deviation. That's what that means. Okay. All right. So if you have a really small standard deviation, let's say that your standard deviation was 1, then that means the typical person is only 1 away from the average, which means, hey, if you had an average of 78% on this test, for example, and the average person is only 1 away from the average, that means everybody was really close to each other. Whereas if on some other test the standard deviation was 20, then that means a typical person is 20 points away from the average. That means that the average distance away from the average is quite big, which means the numbers are spread all over the place. All right, so that's my best description of standard deviation for you. And it's time to just kind of review here. If you wanted to get a standard deviation, you look at this part right here, and that tells you the average distance from the average. It's not exactly that, but that's the kind of the layman's description of what it is. All right. So we're going to be talking more about distribution someday, but we actually aren't going to get to all of that, the normal distribution, this year. But you can look forward to learning that in the future. And that's all we have for the video for today on stats. Have a great day.